Okay, next one. Similar question. We've just gone from 2 to the x. The previous one was 2 to the x. This time I'm graphing 1/2 to the x. But we're going to do the same basic thing. Do my table of values. So that'd be 1/2 to the -3, which is 2 over 1 cubed. Just move those guys, which would be 8. 1/2 to the -2. 2 over 1 squared. Just move everybody. Change the exponent to positive. So 4. 1/2 to the -1. Move everybody. So I have 2 to the first, or 2. 1/2 to the 0 is not 0. Anything to the 0 power other than the number 1, or excuse me, anything to the 0 power other than 0 is 1. And then we've got 1/2 squared for 2, except that'd be wrong too. 1/2 squared would be 1/4, and then 1/2 cubed would be 1/8. And so then drawing this curve, I'm going to do the same thing as kind of cheating a little bit. I'm going to give myself a little more room here, so bear with me. Cheating a little bit, kind of doing the same thing that we did before. There's 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, -1, -2, -3. So I have -3, 8, which we're going to really, it's going to be a horrible sloppy graph, and for which I somewhat apologize. Somewhat. I have the world's worst handwriting. Or maybe not the world's worst handwriting, but I could probably give anybody a run for their money on that. So there's -3. -3, 8 would be right about there. -2, 4 would be right about there. -1, 2 would be right about there. 0, 1, right about there. I left out 1 there. Let's add that. Maybe I'll go back and fix those notes sometime. 1, and that'd be 1, 1/2. So here's 1/2 right about there. So 1, 1/2. 2, and this is supposed to be 1/4. I didn't do a good job here. And if I weren't lazy, I'd start the whole video over and do it again, but I am lazy, so we're not going to start off the whole video again. I did write 1/4 there, but I forgot to put 1/4 there. But 2, 1/4 would be right about there, and 3, 1/8 would be right about there. Connect my dots. And we see we got that same basic shape again, and we get to say the same stuff about it. The domain, it's still left to right, your x's. Now over here, it's going nearly straight up. And I should have said, be a little more specific here, it goes nearly straight up, but it's also going a little bit to the right. It's going straight up and right. Nearly straight up, but slowly to the right. Which is why then we got -infinity to infinity, that it was going left and right forever. It's going slowly to the right here, but it is going to the right. Over here, still nearly straight up, but also to the left slowly. And down over here comes close to x equals 0, but does not touch. That says tough, not touch. So my domain, again, domain is left to right. it's going slowly to the left, but ever so slowly to the left forever, to the right forever, so my domain is still negative infinity to infinity. My range, low to high, low is still over here, almost x, or almost y equals 0. That's not an x, that's not supposed to be x, that's supposed to be y. This is not being a good afternoon for doing videos, I guess. Almost y equals 0. So my low is almost 0, so parentheses. My high going nearly straight up, so 0 to infinity. And my horizontal asymptote, still going to be y equals 0. So notice we have that same basic information that we did before, that the domain was negative infinity to infinity, the range 0 to infinity, the horizontal asymptote y equals 0. Same thing here. The difference here, since this base was less than 1, still positive and less than 1, the orientation of the curve is this way. For a base greater than 1, the orientation of the curve is like that. So there's the two differences there about a base greater than 1, a base less than 1, but still positive bases. We're only going to deal with positive bases. And notice they still both go through the point 0, 1 because of the fact that anything to the 0 power other than the number 0 is 1. So we have all the generalities written down here. In general, f of x equal a to the x, where a is greater than 0, a is positive, and a is not equal to 1, has a domain of negative infinity to infinity, which tells us that the exponent can be any real number. Range is 0 to infinity, which tells us that our answers we get, because range are what comes out of the function, you can think of them as your answers. The answers we're going to get from f of x equal a to the x are positive numbers, and there's a horizontal asymptote is of y equals 0. Also, we can note that both these guys, regardless of the orientation, both of these guys pass the horizontal line test, which meant the functions are 1 to 1. And one of the things we learned way back in chapter 2 was that if a function was 1 to 1, it has an inverse. And we'll be seeing that inverse in the future someday. So what we're going to do next is we're just going to do a little bit of translation work, moving things left, right, up, down, that sort of thing. And it's going to follow the same rules that we did before when we did translation work, except when we've moved around like origin points before, we're going to move around this point 0, 1 because the curves are always of the basic a to the x curves. They're always going to go through the point 0, 1. And we're going to move around the asymptotes because they both had an asymptote at y equals 0. Okay. In each of the following, use transformations of f of x equal 2 to the x to graph the following. Use the graph to determine the domain, range, and asymptote. So again, let's just put it up here, my basic shape, which a lot of books I've come to realize call that the parent graph. I just like basic shape. So the basic shape is this. There's my basic shape. So we want to graph 2 to the x plus 4 minus 6. So minus 6, that's going to be a vertical shift down 6 units. The plus 4 inside the exponent. Well, when things are inside the function, when we did parabolas and it was in the square, and when we did square roots and it was inside the square root, numbers inside are horizontal shifts. Horizontal shifts work backwards to what you'd expect, and so this is going to go left 4 units. So we think about that point right there, that 0, 1 point. We're going to go down 6. I'm going to think ahead a little bit. Let's redo this since I have to go down 6. Let's start up much higher. So there's that 0, 1 point. We're going to go down 6. I'll do my counting in red. 1, 2, 3, 4, 5, 6. And left 4. 1, 2, 3, 4. There's that new point, and I guess we'll graph things in green again. So down 6, left 4. There's that new point. And then we're also going to move the asymptote. The asymptote was right there, so move that down 6 as well. So counting from there, 1, 2, 3, 4, 5, 6. That's where that new asymptote is going to be. That we're going to move both this 0, 1 point, so we start right there, because that's kind of the original point. Move that down 6, 1, 2, 3, 4, 5, 6, left 4, 1, 2, 3, 4. So we move that. Then we move the asymptote. So moving, kind of think of the x-axis. We're moving the x-axis down 6. 1, 2, 3, 4, 5, 6. Notice going left to right doesn't change anything. So I don't have to worry about the left to right when I'm moving the x-axis. Then just draw that same basic shape, and that's good enough. I am not looking for major works of art here. My domain. It still goes left forever and right forever. The domain on all of these basic ones, a to the x, always going to be negative infinity to infinity. Now the range can change. Remember, range is low to high. So I moved my asymptote, I moved my x asymptote down 6 units. And so this is now x equal negative 6 here. 1, 2, 3, 4, except it's not x, it's y, excuse me. Y equal negative 6, 1, 2, 3, 4, 5, 6. So my low point is almost negative 6, so parentheses, but then it goes up forever. So 6 to infinity, and my horizontal asymptote would also be that y equals negative 6. And we did that one. Okay, let's end this video, and on the next video we'll do the next curve.